let's now try and implement some series programs using this particular for loop. We'll start with a simple series. In fact, the series which we have done at the beginning, suppose if the series is given as say 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 and so on till say 1 by n. If I ask you to find this particular series sum or any series sum which is supposed to be implemented using a for loop, what will be the logic behind that? Before we write the program, let's understand the logic of this particular code. Observe this particular series carefully. Check out for numerator and denominator. So since the denominator for the first term is not given, so I can make this as 1 by 1. So I have 1, 1, 1, 1. All the terms in the entire series, the numerator is what? 1. So I'll say, let's summarize this particular series as say 1 divided by. Since it's a constant, I'll put the same constant. Then go and check the denominator. For every series program, follows particular practice. When a series is given to you, first identify what is a numerator. Is this numerator a constant or a changing? If it is constant, keep the constant as it is. If it is changing, let's see what I'm supposed to do. So I'll say 1, 2, 3, 4, so on, it changes up to n. So it means that the denominator is changing. Why don't we use this denominator as say I? So it means that instead of adding a 1, 2, 3, 4, you add what? 1 by I to the series. Where your I goes from what to what? 1 to n. So let's put a summation symbol and say I equals to 1 to n. The other way of asking the same question is this also. So whenever a series is given to you, identify how that particular series works. First, identify the numerator. If the numerator is a constant value, then set that as constant. If the numerator is changing, then identify that as a variable. Similarly, go to denominator. Check whether it is constant or changing. If it is constant, then keep that constant. If not changing, then identify that as a variable. If a series is given to you, then in that case, summarize this to an expression 1 by I. So it means that I have to write a for loop. A summation symbol always hints towards the use of for loop. So I'll say I equals to 1 to n. And here I'm supposed to take this particular I in steps of 1. And then 1 by I is nothing but the series value at this place. Suppose if the series is given as say 1 by 2 plus 2 by 3 plus 3 by 4 plus 4 by 5 plus so on. Now, how to summarize this particular series? First, as usual, again identify the numerator. Is this numerator constant or changing? Changing. Changing in the sense, express that as variable I. After that, denominator. Is this constant or changing? Changing. If it is changing, either you can associate a fresh variable or what you can do is, you can check, can I express this denominator as a numerator variable? Yes, I can express this denominator as a numerator variable. So here, when I is 1, it is 2. When I is 2, it is 3. When I is 3, it is 4. So it means that I can say I plus 1. And here, I can put a summation symbol of I, where I changes from 1 to n. So I have this particular series. Suppose if I have a series of this sort, 1, say by 2 plus 2 divided by say 5 plus 3 divided by say 7 plus 4 divided by say 9 and so on. How do I get this particular series? So now what you can do is, if I say this as, this has to be 1 by 3. The first term has to be 1 by 3. 1 by 3 plus 2 by 5 plus 3 by 7 plus 4 by 9 and so on. If I identify this as series, so let's summarize this series. As usual, I goes what? In the numerator changing, so express this as I. Then, can I express this denominator as a variable? Can I express this denominator as a numerator variable? When I is 1, it has to be 2. When I is 2, it has to be 5. When I is 3, it has to be 7 and so on and so on. If you are able to understand it at the first execution itself, if you are able to understand this at the first instant, then you can proceed further. If not, blindly take one more variable, say j. So here, I'll take I as 1 to n, and here it will be in steps of 1, I got I plus 1. Your j will be again going from 3. So j goes from 3 at the first term and it goes up to some value. So here your j will go as j equals to j plus 2. So I changes into one step, j changes in multiple steps, and here your numerator is I and denominator is j. This is one way. Now, some intellectuals where you have a very good logical reasoning, you can express this as one term itself. So let me say summation, numerator changing, hence I, denominator. If you apply stress on your brain, if you apply some thinking, some reasoning to this particular example, you will be able to express this denominator as a numerator term. Your denominator term is 2i plus 1. When I is 1, 2 into 1 plus 1 is 3. When I is 2, 2 into 2, 4 plus 1, 5. When I is 3, 2 into 3, 6 plus 1, 7. So here, again, I will go from 1 to n. I will go as summation of I divided by 2i plus 1. So you can implement any of these series examples onto a for loop. So what is the basic requirement, basic operation which you are supposed to do? First thing is identify the series. Identify the series. Once a series is identified, then what I can do is I had to identify the numerator. First go with numerator. Is this numerator a constant or changing? If it is constant, then express that as constant. Then go to denominator. Check denominator if it is constant or changing. If it is constant, put the constant term as it is. If not, then what I need to do is I need to go back and express the denominator in terms of numerator variable. If true, if you are able to do out some logical reasoning, definitely you can express the denominator as a numerator variable. If not, you have to express that as a denominator changing variable. Now let's look at the program which is used for implementation of that particular series program. We have discussed the three series altogether: 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on. And then we change the series. So I'll put up those series again when we discuss in the entire program session. So as usual, I'll ask the user to enter the last number, that is n, and then whatever the expression which is constructed, the first series which I used was 1 plus 1 by 2 plus 1 by 3 and so on. So here, if you observe, the numerator is constant, so hence numerator is 1. The denominator is changing, so I have 1 by 1, 1 by 2, 1 by 3, 3, 4, 5 up to n. So denominator changing as 1 to n. So why don't we express that denominator as I? So the expression which I constructed was summation of 1 by I, where I was taken from 1 to n. So what are the expression which you constructed? This expression should be added with the accumulation variable, and this time the accumulation variable will be float. Why float? Because when I say 1 by 2, 1 by 3, 1 by 4, the tendency is to get fraction values. So hence I'll say that as s equal to 0. Let's work with this particular example with say 3 terms. Suppose if n is given as 3. If n is given as 3, how this for loop works? Initially your s is 0, your I is what? Initially 1. So 1 less than or equal to 3, true. S equal to s plus 1.0 by I. So I is 1, 1.0 by 1 is 1. So s will be now 1. When you go back, I becomes 2. 2 less than or equal to 3, true. True in the sense, now here 1 s equal to s plus s is what? 1 plus 1.0 by 2. Now you will understand why I have placed a 0.0 value at this place. 1.0 by 2. Why? 1.0 by 2 indicates the result as 0.5. If this could have been 1 by 2, in that case this could have said that as only 1 by 2 would have been said as 0 rather than 0.5. So here 1 by 2 is 0.5. So 1.0 by 2 is 0.5. So 1 plus 0.5 is 1.5. So now I becomes 3. When I becomes 3, so 3 is 1.0 by 3. So the previous value of s, that is 1.5 divided by 1.0 by 3 is 0.33. So hence the result is 1.83 at this place. So here s is considered as 1.83 because when I go back, I is 4. Stop this particular operation. So here the expression which I constructed works with this particular operation. What if this series would have been said as say 1 by 2 plus 2 by 3 plus 3 by 4 plus 4 by 5, the second series which I explained. So here your summation was I divided by I plus 1. So how I could written the expression? Still the same for loop button we use. The only change would have been this particular expression. How this expression will change? S equals to s plus I divided by I plus 1.0 and a semicolon. So here I plus 1.0. Now see here 1.0 is a float value. If the expression contains a constant term, then say 0.0. If the expression has only variable, say, then you have to use typecasting. So S equal to S plus I divided by I plus 1.0. If I go with the third case which I said, 1 by 3 plus 3 by 5 plus, 2 by 5 plus 3 by 7 and so on. Here I consider expression as I divided by 2i plus 1. So you can say S equal to S plus I divided by 2i plus 1, 2 asterisk I plus 1.0. Or we constructed even this as I by j, where I was moving from 1 to n, and j, we started with that j as 3, but we never know what will be the final value of j. So here I have numerator as separate variable and denominator as separate variable. So how do I express that numerator and denominator as separate variables? Let's look at this particular code. So I have a code for you. I'll say for. Now here I have two variables. Let's set two variables as I as initially 1, and then rather than placing a semicolon, put a comma and say j equals to 3. The initial value of I is 1 and j is 3, and then a semicolon. Condition is known with what variable? Condition is known only with variable I. So I'll say I less than equals to n, and after that I'll say I equals to I plus 1 and j has to be changed. So j will have a semicolon, j equals to j plus 2. So here we have been saying this particular series which contains numerator and denominator separate variables. So here I has been placed in numerator and j has been placed in the denominator. So whenever a loop has to be written with two variables, this is how it has to be written. So since the numerator starts with the value as 1, so I is 1, and then place a comma rather than a semicolon and set j as the initial value, that is 3. So now this combined is even. Condition is known with what variable? Condition is known with only I variable, so hence I less than equals to n. Now this is my E2, and here I has to be incremented by 1 and j has to be incremented by 2, hence this entire thing is E3. Again place a comma rather than a semicolon. So there has to be two semicolons in the entire for loop, and if I have multiple expressions with either E1 or E2 or E3, they have to be separated with a comma. So here I can say S equals to S plus I by j. Now here the numerator and denominator both are variables, there are no constants. So in that case what I'll do is I'll use typecasting. So I'll say float I by j. So I can say either float I by j when numerator and denominator both are variables. If the expression contains a constant, preferably use a 0.0 concept. If not, associate this particular expression. Now we'll modify this example with one more series. Suppose if the series is given in this fashion, say 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 and so on, minus and so on. If there is an alternate plus minus plus minus plus minus, I have applied to a simple series. So this can be extended to any series example of your choice. So here if I had to summarize, now forget about the sign at this particular place, let's identify all as plus. So what I'll do is I'll summarize this as 1 by I. So I'll take a for loop at this place. So for I equals to 1, I less than equals to n, I plus plus. But here I'll say S equals to S. Should I say always plus? Should I say always minus? In this case I have to alternatively say plus minus. For that what I'll do is let me use a variable as sign set with 1. And here I'll say S equals to S plus sign multiplied by 1.0 by I. And before I go back, what I'll do is I'll change this particular sign. Now in this case I is plus 1, hence this 1 is multiplied by 1.0, so it will be plus 1. So what I'll do is I'll say sign equals to sign asterisk minus 1. Now how it works? Now initially sign is 1, so hence it says 1, initially S is 0, so I'll say 0 plus sign is 1, 1 asterisk 1.0 by 1, that is 1 by 1. So we got this term and this term. Sign equal to sign into minus 1. What is sign value now? 1. 1 into minus 1 is minus 1. So sign stores now minus 1. Go back to I becomes 2. S equal to S plus, the previous value of S plus sign. Sign is minus 1. Minus 1 asterisk 1.0, that is minus 1.0 by I. So minus 1.0 by I is minus 1 by 2. After that, sine equal to sine into minus 1. What is the value of sine? Minus 1. Minus 1 into minus 1 is plus 1. So when you go back, I becomes 3. S equals to S plus sine asterisk 1.0 plus sine. Sine is 1. 1.0 by 3. So plus 1.0 by 3. Sine equal to sine into minus 1. 1 into minus 1 is minus 1. Go back, I becomes 4. So S equal to S plus sine. Minus 1 multiplied by 1.0 by 4 is minus 1 by 4. So I get alternative plus minus. Any example where the sign is alternatively changed, take just a sign variable, set that as 1 and then multiply the expression with that particular sign and keep on toggling the sign from 1 to minus 1, minus 1 to 1 by multiplying with minus 1. So these are some of the examples which you're supposed to consider whenever the series examples are supposed to be done. So we have experienced 3 different types of series. The first series where a numerator was constant, denominator was changing. The second series where numerator was changing and denominator was expressed as a numerator variable. The third series where numerator was delta separate variable, denominator was also delta separate variable. And the last series where the sign was changing. When the sign is changing, in that case you can have these sign variables declared of type integer and toggle this particular sign from 1 to minus 1 and keep on multiplying this with values. If I ask you to modify this particular code with the first number with minus sign, second number with plus sign, no big change in this particular code. Yes, just you're supposed to assign sign as minus 1 initially, and the rest of code will work automatically. This is how we manage the series programs which are used with this particular for loop. Thank you.